discussing about another serial communication standard, which is known as the HDLC. Okay, so HDLC, in your first module, you might remember when we discussed about the embedded system model. We discussed about an example about the communication network OSI layer. Okay, that is a conceptual layer where you have 7 layers. Okay, in that you might have seen this particular data link layer. Okay, so HDLC is nothing but it's a protocol that is used in the data link layer. Okay, so the full form of HDLC, it stands for high level data link control. Okay, so this is actually developed by IBM, but it's an advanced protocol which is developed from SDLC, which is known as synchronous data link control. Okay, so everything should be based on a standard. Now HDLC is an ISO standard. Now the main use of HDLC is it is actually a transmission protocol. Okay, which is used at the layer 2 of the OSI layer, which is meant for which is actually a model for data communication. Okay. It embeds information in a data frame that allows devices to control data flow and also to correct the errors. Okay, so basically this is a bit oriented, that is a stream of bit is transmitted. Okay, and control the ways to control the devices, all these things are also transferred in the form of bits rather than characters. Okay, so that is why HDLC is it's a bit oriented protocol. Now, it is very widely implemented. Now, the reason why it is widely implemented is because it can be used for half duplex communications and also full duplex communication. Okay, you can use for half duplex and full duplex. Also, you can if you have communication between two devices, point to point, that is peer to peer, or you can have a point to multi-point network communication. So that also you can HDLC supports. Also, it supports several modes of operation too. Okay. So this is an example of different types of. Before you come to that, we will see what are the different types of stations that is present in a HDLC. Okay. Station in the sense the way in which the communicating devices are configured. Okay. So you have a primary station, you have a secondary, and also a combination of both primary and secondary. Okay, so primary, secondary, and combined stations. When you come to primary station, see, you always have a person that is controlling everything. Okay, so you have the data link layer where you have a device that is controlling everything. So that is known as the primary station. Now its responsibility is to send the data, issue command, issue responses. Okay, all these things, it is controlled by the primary station. Now, if there is an error, that error recovery also takes place at the data link layer. Okay. Secondary station is nothing but, it's under the control of the primary station. It does not have any special ability rather than just responding to what the primary station is saying. So it has no ability, or it is directly, it is responding to what the primary station is saying. Okay. Now it is only activated when it is requested by the primary station. Unless and until there is a request to the secondary station, it remains inactive and it responds to only the primary station. Okay. Now, how does it send? It sends in the form of frames. Okay. Now there are different ways in which the data is sent. Some layers sent in the form of packets, some in the form of frames, some in the form of bits. In this particular data link layer, the data is sent in the form of frames. Okay. Combined station, it's a combination of both the primary and the secondary station. Okay. Means that they can send and receive, they issue commands, they take responses without any permission from any other station on the link. Okay. They are, self-sustainable. Okay. They can stand their own. Okay. Now each combined station is in full control of itself and it does not depend upon any other station. Okay. So you can issue both a command and a response. Okay, because it has a primary here. Next, coming to the configuration. Basically, when you discuss the configuration in which HDLC works, you will you will talk about only two: unbalanced configuration and a balanced configuration. The symmetrical one is just to give you an idea. That's all, because it is not used currently. Okay, the unbalanced configuration and the balanced configuration. So what do you mean by unbalanced configuration? Is nothing but, you have one person who is only controlling and the other person is just responding. So that is you have a primary station and you can have one secondary or many secondary. Okay. So the unbalanced condition arises because one station controls the other station. That is why it is known as an unbalanced configuration. Okay. Now the application of this type of configuration is you can use it for full duplex or half duplex operation, point to point, where you have one primary and one secondary, point to multi-point. You can have one primary and multiple secondary stations. Okay. This is the representation of how a HDLC unbalanced configuration will look like. You have a primary which is issuing the command, and you can see the secondaries are giving the responses. Contrary to that, you have the balanced configuration wherein you have two or more combined stations. Now, each of these stations, they are responsible for their data and their responses and everything. Okay, so each station has equal and complementary responsibility compared to each other. Okay, so this is how HDLC balanced configuration will look like. Okay, the third type, it's not used widely because it is too independent point-to-point unbalanced configuration. Something it will look like this. Okay, but this is not used. Same way, you have different modes of operation for HDLC. The mode indicates who controls the link. Okay, now three modes of operation. You have a normal response mode, asynchronous response mode, and asynchronous balanced mode. The asynchronous response mode is not used that much. Okay. So first one, the normal response mode, where the primary initiates the transfer. Okay, here the primary does everything. This is when your HDLC is working in a unbalanced configuration where you have your primary which is controlling your secondary. Okay, so the secondary station can only transmit a response, and that too only when it is instructed to do so by the primary. Okay, so once the last frame is transmitted by the secondary station, it has to wait. It has to wait for for any permission from the primary. Okay, no matter what it has to transmit, it has to wait for the permission from the primary. So that this shows your unbalanced configuration. So that is your normal response mode. Okay. When you come to asynchronous response mode, the primary station doesn't initiate transfers to the secondary station. No, what it does is it reduces the overhead because no frames need to be transferred to give the secondary station permission to initiate the transfer. Okay. So due to the fact, because this mode is asynchronous, the reason, because it is asynchronous, the secondary must wait for, it has to detect a idle channel. Okay, only when there is a channel that is idle, then only it can transfer any frames. Okay, even though you don't have any primary to control it, it has to wait. Okay, so this is when the ARM link is operating as half duplex. Clear? So this is the way how it is working as a half duplex. No, this particular mode it's only suitable for half duplex application is only suitable if you have only maximum two persons communicating. So usually for point to point links only, this is asynchronous response mode is better. Okay. Next is the asynchronous balanced mode, where contrary to your normal mode, you have your combined station. So here there is no permission for from any station required. Okay, so most frequently in multi-point lanes where primary station controls the links. Okay, so there the asynchronous balance mode is used. Now coming to the frame structure, we have discussed that different layers transfer the data in different formats. Okay, some have packets, some have frames. The data link layer, it transfers in the form of frames, so it has a frame structure. Now, frame structure does not only contain the information, but it has certain control bits and address locations, certain indications as to what that particular frame carries. Okay, so based on that, you have three classifications of frame. One is the I-frame. The I-frame. Okay. Now, when you see the three classifications, you can see that there are certain things in common. Okay. In all the three, the common thing is the flag, the address, the control, FCS, and the flag. Okay. So you can see that there's a start flag and there's a end flag. Okay. Then only thing is there is difference between the information. Okay. The S frame does not contain any information. Okay. S is supervisory frame. U is frame. Okay. So we will discuss what these flag address control FCS are. Before that, let us discuss what these how are they different from each other. Okay. Now, in the case of your information frame, they carry user data. Okay. As the name suggests, the information frame, that information part carries the data. Okay. They also include the flow and error control information. Okay. The first bit of the control field of the iframe is a 0. Okay, so that we will understand when you learn more about your flag structure. Okay, now the S frame is nothing but a supervisory frame. So this it is something which issues a command or control to the device. So naturally, it does not contain an information field. Okay, third one is an unnumbered, and it is actually reserved for link management. Okay, link management. Uh, so what is to be managed, that is given in the information frame. Okay, that particular data is passed in the information frame. Okay, so these are the three types of frame structure that is present. You have I frame, S frame, and U frame. Okay, now frame structure, the size of each fields. Usually your flag, start flag, and the end flag both are 8 bits each. Then you have an address field indicating to where it is or which device it is intended to. Okay. That is also 8-bit. You have the control field, which is either 8 or 16. Then you have the information field, which is variable. Okay. It contains the data. Then you have the FCS. FCS means it's a it's a bit pattern which is used to see if there is any error. Okay. Say the same way we used parity check for your UART. Here you have a 16 or 32-bit frame check sequence. Okay. Then you have a closing flag. Okay. So you have a start flag and you have an end flag, which are of 8 bits. So usually the start flag and the end flag will be beginning with 8-bit pattern, which is you have a starting 0 and an ending 0. In between you have 6 ones. So that is indicating the beginning and the end of an HDLC frame. Okay. So if you have 7 ones or more and less than 15, it indicates that there is a problem on the link. Okay, the link has a problem. Either the station has a problem, and we have to abort whatever transfer is done. Okay. Now, if you have 15 ones or 16 ones, it means that the channel is idle. Okay. Okay. Then there is a time between the transmission of the actual frame, one frame. After that, there is a time between the initiation of the other frame. That is known as an interframe time field. Okay. So this is how the flag field is. Talking about address. Now, each of the station on the link, they have a unique address. Okay. In the unbalanced configuration, the address field, A field responds to the, refers to the secondary station. Okay. Whereas in the case of your balanced configuration, the command frame contains the destination address, and also the response frame has the sending station's address. Okay, clear. So that is the difference between the A field in the unbalanced configuration and the balanced configuration. Okay. Now the control field, it is used to control the communication process. Okay, so there are three control field formats. Now, first one is the information transfer format, where the data transmission between two devices occur. Also, there is a supervisory format where you have acknowledge the frames, or if there is an error, it requests for a retransmission. Okay. Now, in your U frame format, there might be you have to initialize the contact, you have to disconnect the link, or maybe there is some other management functions related to the link devices. So for that format, you will have the control of field taking that particular bit format. Okay. Then also there is a pole bit. Okay. This is how a control field will look like. Okay. So everywhere there is a P/F. It's a pole and final bit, which indicates that if you have to recognize it, it is to be set to 1. Okay. Or else it is ignored. Okay. Now, this is the information field. No, it is not always present in a HDLC frame, indicating that in the I frame and the U frame only it is present. Okay. So it is only present when the information format is being used in the control field. Okay. Now it contains the actual data that is to be transmitted to the receiver. Also, there is an error sequence. As we have discussed, it can be a 16-bit or a 32-bit cyclic redundancy check. Now, that is a type of algorithm that is used for error detection. Okay. So with this, we stop HDLC here.